Hello students, today we will be dealing with post-harvest handling, marketing and distribution of foods. Coming to the definition of post-harvest system. Properly considered, Spurgeon says the post-harvest system should be thought of as encompassing the delivery of a crop from the time and place of harvest to the time and place of consumption with minimum loss, maximum efficiency and maximum return for all involved. Now, we will see the factors that affect the storage quality of the grain, which include temperature, humidity, length of storage, insects and pests. Respiration in grain legumes. Grains respires, taking in oxygen from the air and converts the nutrients stored in its cotyledons into heat, carbon dioxide and water in the form of moisture. These compounds are discharged into the atmosphere through the process of respiration as illustrated by the general equation, that is, carbohydrates are converted to oxygen, carbon dioxide, water and heat. The process also induces the growth of molds and insect pests, which further cause reduction and deterioration in grain quantity and quality. We will see the interactions and factors affecting the respiration. The main factors with direct influence on respiration of grain include temperature of storage environment, moisture content of the grain, presence of insects, pests in the grain, presence of microflora such as fungi and bacteria in the grain, physical state of the grain, amount of oxygen in storage environment. Respiration and dry matter losses. Grain itself and the microbial contaminants respire slowly when stored dry. However, if the water availability is increased to 15 to 19%, moisture content activity such as in wheat, spoilage fungi, particularly Eurotium species, Aspergillus and Penicillium species grow, resulting in a significant increase in respiratory activity. Now, this can result in an increase in temperature and sometimes spontaneous heating from the colonization by a succession of fungi, resulting in colonization by thermophilic fungi and actinomycetes. Now, these activities come to an end at about 55 degrees temperature. Coming to temperature, the rate of all chemical reactions including respiration increases with temperature. Consequently, respiration and deterioration in grain also increases with temperature. When the temperature and moisture level of the grain are correct, then there will be only the enough respiration to keep the embryo alive. Grain stored at high temperatures, therefore, respires and spoils quicker than well-dried grain kept in a cool, dry place. Higher temperatures also favor multiplication of insect pests, fungi and rodents, all of which spoil the grain. Some important points to be considered during the storage of grains are: mites don't develop below 5 degrees Celsius nor insects below 15 degrees Celsius. Most storage fungi don't develop below 0 degrees Celsius. The effect of temperature on the organism is correlated with the amount of moisture present, as rise in temperature corresponds to the decrease in moisture content. Temperature has profound impact on the rate of metabolism, growth, development, reproduction and general behavior and distribution of pests. The low temperature at which insects are able to develop is between 15.5 to 18.3 degrees Celsius. The optimum temperature required for most of insects between 29.4 degrees Celsius to 32.2 degrees Celsius. The fatal high temperature for insects ranges from 50 to 56 degrees Celsius, whereas for microorganisms thermal requirements differ for growth and care, commonly classified as psychrophils 10 to 20 degrees Celsius, mesophils 25 to 40 degrees Celsius, thermophils 50 to 60 degrees Celsius, and mostly fungi and bacteria die within 10 minutes at 55 degrees Celsius. Dry spores and fungi survive at 87 degrees Celsius at 30 minutes, while only few survive at 121 degrees Celsius for the same length of time. Under Indian conditions, some of the mites develop faster at a temperature between 18 to 22 degrees Celsius. Moisture in the grain. Grain legumes, like other food crops, contain moisture at harvest. The amount of moisture they contain is of great consequence of the crop is to be stored for any length of time from 1 or 2 days upwards. To reduce crop respiration and spoilage and to extend its shelf life, it is essential that following harvest its moisture level be systematically reduced to below certain level well defined limits. Moisture in the grain can be removed by drying. The amount of moisture fluctuates according to the temperature and relative humidity of the surrounding air. Moisture content of the grains below 13% arrests the growth of microorganisms and mites. Moisture content below 10% limit the development of most stored grain, pests and insects. The rate at which grain will lose or gain the moisture generally depends upon its condition, type of grain and extent to which it is exposed, such as wheat has 8 to 10%, paddy has 20 to 24%, maize and sorghum has 20%. The microorganisms are the hydrophytes, which are greater than 90%, mesophytes 80 to 89% and xerophytes less than 80%. Coming to nature of moisture in the grain. Water or moisture in the grain is of two distinct types. One is chemically and physically bound. Chemically bound water is part of the chemical composition of the grain. This is also sometimes called water of composition. Removal of such water would therefore mean alteration of the entire grain structure. This would not only affect storability and viability of grain, but also its economic value and is thus undesirable. Physically bound water, also known as free water, is divided into two types: adsorbed and absorbed water. Elimination of moisture. Dry grains has 9 to 13% moisture. Less than 9% not favor the development of insects. 11 to 14% optimum for all stored insects. Greater than 14% for molds and greater than 25% for bacteria and yeast. Long storage at greater than 15%, which is unfit for human consumption. To prevent moisture, we need to dry the food grains well before storage. Prevent water leaks from roofs, doors and ventilators. Provide high plinth in the store. Make the floor moisture proof. Use wooden dunnage or polythene sheets. Do not stack the grain bags touching the walls. Do not open the stores for long periods during the rains. Damage by insects. Damage to the infected food can be broadly classified as loss of weight. Losses in the weight can be known by weighing in and weighing out of particular lot of produce. Insect infestation can be estimated by count or weight method, weight by volume ratio before and after storage. Loss of quality. Insects eat away the endosperm, which affects the quality nutritive value. Gluten quality is also lost in case of wheat. Loss of hygienic value occurs when the grains is contaminated with excreta of rodents, dead insects and insects excreta. Sources of infestation. Field infestation, transportation, infested stores, infested stocks, infested gunny bags, cross infestation. Coming to fumigants, it is a process of applying toxic fumes, vapor or gas of a substance to the infested grain for a certain period in a reasonably airtight chamber. Fumigation should not be done more than 2 times. Third fumigation is only done when it is absolutely necessary. A prophylactic spray on the stack and around the stack, floor and walls with malathion 0.5 to 1% is recommended before fumigation. Rodents. Common rodents infesting food grains are roof rat or black rat, brown rat, house mouse and bandicoot. Coming to the horticulture, current production of around 32 million tons accounts for about 8% of the world's fruit production. Diverse agroclimatic zones in the country make it possible to grow almost all varieties of fruits and vegetables in India. 8 major varieties of fruits dominate India's export markets. These include mangoes, bananas, citrus fruits, apples, guavas, papaya, pineapples and grapes. Production of these fruits in India makes a sizable contribution on a global scale. In India, it was estimated that between 25 to 50% of the total grain value, that is quantity plus the quality, is lost between harvest and consumption in developing countries. In spite of new storage methods, the losses of up to 9.3% have been recorded in India. The seed stock, which constitutes about 10% of total production, also suffers from 1.2 to 5% damage. Now, in India, it has been estimated that 3 to 5% of grains in storage is destroyed by insects and pests. International Rice Research Institute estimated post-harvest losses in Philippines as harvesting loss is considered to be 1 to 3%, due to handling 3 to 7%, threshing 2 to 6%, drying 1 to 5% and storage 2 to 10%. Although India is the largest producer of fruits in the world, its production per capita is only about 100 grams per day. Between 20 and 30% of total fruit production goes to waste owing to spoilage at various steps of post-harvest chain, reducing per capita availability of fruits to around 80 grams per day, which is almost half the requirement for the balanced diet. Fruit production in India has recorded a growth rate of 3.9% on an annual basis, while the fruit processing sector has grown at a rate of about 20 per annum. Growth rates have been considerably higher for the production of frozen fruits and vegetables and dehydrated fruits and vegetables. Over 4,000 fruit processing units with an aggregate capacity of more than 12 lakh million tons exist in India. Approximately 20% of the production of processed fruits is exported, while the remainder is consumed by the defense sector, institutions and households. Mangoes and mango-based products account for 50% of the exports. India is said to be the second largest producer of vegetables in the world, ranking next to China, and accounts for about 15% of global vegetable production. Coming to the status of post-harvest handling, Asia and the Pacific region has witnessed rapid growth in horticultural development. Changes in dietary habits owing to increased incomes continue to accelerate demand for horticultural produce in the region. This increased demand must be met in an environment of shrinking land and water resources. At the same time, developments in science and technology could provide an opportunity for intensifying the production of horticultural produce. Poor infrastructure for storage, processing and marketing in many countries of the region contributes to a high proportion of waste, which averages between 10 to 40%. Major infrastructural limitations also continue to impose severe constraints to domestic distribution as well as to the export of horticultural produce. Considerable waste occurs owing to the fact that small farmers lack resources and are unable to market their produce and implement suitable post-harvest handling practices. Spoilage of fresh produce is also accelerated by the hot and humid climate of the region. Post-harvest management and processing of horticultural produce has assumed considerable significance in light of increasing demand for fruits and vegetables in the region. We will see the estimates of losses in food grain at different stages. In threshing yard, the loss is seen to be 1.68, in transport 0.15%, in processing 0.92. During storage, the loss by the rodents is 2.5, by the birds it is 0.85, by insects it is 2.55, and due to moisture it is 0.68. The World Food Conference convened in Rome in 1974 drew attention to the concept of post-harvest food loss reduction as a significant means to increase food availability. The Special Action Program for Food Loss Prevention of the Food and Agricultural Organization of United States initially focused on durable food grains owing to their prominence in developing country diets. An expert consultation on food loss prevention in perishable crops, mainly covering fruit and vegetables, was held in Rome in 1980. Although India is a major producer of horticultural crops, many Indians are unable to obtain their daily requirement of fruits and vegetables, and the Human Development Index is very low. Considerable quantities of fruits and vegetables produced in India go to waste owing to improper post-harvest operations and the lack of processing. This results in a considerable gap between gross food production and the net availability. It should be noted that the production of fruits and vegetables is of significance only when they reach the consumer in good condition and at reasonable price. The concept of placing exclusive emphasis on increased production of fruits and vegetables is self-defeating. It is important to see how much of the produce goes through marketing channels and finally reaches the consumer. Efforts should be made to integrate production with post-harvest food availability. It is known that food loss reduction is normally less costly than equivalent increases in fruit production. Reduction of post-harvest losses is essential in increasing food availability from existing production. The success of production lies in the proper distribution of produce and its subsequent utilization by the consumer with zero waste in the process, that is 100% utilization of production in one form or another should be the motto. Opportunities exist in both domestic and international markets for fresh and processed fruits and vegetables. Now coming to the causes of post-harvest losses in horticulture. It is caused by external and internal factors. External factors which lead to post-harvest losses are: first is the mechanical injury. Fresh fruits and vegetables are highly susceptible to mechanical injury owing to a tender texture and high moisture content. Poor handling, unsuitable packaging and improper packing during transportation are the causes of bruising, cutting, breaking, impact wounding and other forms of injury in fresh fruits and vegetables. Parasitic diseases. The invasion of fruits and vegetables by fungi, bacteria, insects and other organisms. It is a major cause of post-harvest losses in fruits and vegetables. Microorganisms readily attack fresh produce and spread rapidly owing to lack of natural defense mechanisms in the tissues of fresh produce and the abundance of nutrients and moisture which supports their growth. Coming to the internal factors, firstly, it is the physiological deterioration. Fruit and vegetable tissues are still alive after harvest and continue their physiological activity. Physiological disorders occur as a result of mineral deficiency, low or high temperature injury, or undesirable environmental conditions such as high humidity. Physiological deterioration can also occur spontaneously owing to enzymatic activity, leading to overripeness and senescence, a simple aging phenomena. Scope and strategies. The unnecessary waste of valuable commodities can be checked by processing into value-added products. Considerable scope exists for both domestic and export trade in fruits and vegetables in India. This will, however, only be achieved with improved distribution systems and processing of these highly perishable horticultural commodities. The even marketing of fruits from areas of abundance to places of scarcity will stabilize fruits and vegetable prices. Proper post-harvest management practices for minimizing losses and for improving marketing are generally not followed in India. In the raw material, no matter how perfect post-harvest operations are, good returns cannot be obtained from poor quality raw materials. The selection of suitable varieties is therefore essential. Linking production to post-harvest operations is essential to optimizing results. Pre-harvest parameters such as selection of proper planting material, crop management, and disease and pest control must be geared toward producing high quality produce. Now, once the crop is ready for harvest, attention must be paid to the harvesting technique or procedure. Poor harvesting practices can lead to irreparable damage to horticultural produce. It is therefore necessary to standardize maturity indices and harvesting techniques for each and every fruit and vegetable in order to minimize damage at the time of harvest. Packaging stations. There is an absolute lack of the concept of packaging house establishments in India. Fruits and vegetables are generally packed in the field without any pre-treatment. Some are even transported without any packaging. A number of important operations are also carried out at packing stations. These include sulfur dioxide fumigation, fungicidal dipping, surface coating with wax, degreening of citrus, ripening and conditioning, vapor heat treatment, etc. Primary processing. Unlike durable crops such as cereals, pulses, and oil seeds, fresh fruits and vegetables are highly perishable and must be marketed immediately after harvesting without primary processing. Fruit and vegetables generate large quantities of valuable waste that ends up as garbage. However, if they are gainfully utilized at the proper time, they can become value-added products. Processing not only renders these commodities edible but also adds value to them. Today, there is considerable interest in processing to add value as well as to reduce losses in fruits and vegetables. Packaging. Packaging is an integral element in the marketing of fresh horticultural produce. It provides an essential link between the producer and the consumer. Owing to its favorable properties, wood has remained the main packaging material for fruits and vegetables. Palletization. Loading and unloading are very important steps in post-harvest handling of fruits and vegetables, but are often neglected. The individual handling of packaged produce in India leads to mishandling and to high post-harvest losses in India. With the introduction of corrugated fiber board boxes, serious consideration should be given to the introduction of palletization and mechanical loading and unloading of produce, particularly with the use of forklift trucks in order to minimize produce mishandling. Coming to storage, the lowest temperature that does not cause chilling injury is the ideal storage temperature for fresh fruits and vegetables. Mechanical refrigeration is generally used for the storage of fruits and vegetables. Available cold storage in India is used primarily for the storage of potatoes. On-farm storage. On-farm storage is required in remote and inaccessible areas of India to reduce losses in highly perishable fresh horticultural produce. The high cost and high energy requirements of refrigeration and the difficulty of installing and running refrigerated facilities in remote areas of India precludes the use of refrigerated storage in many parts of India. Low cost, low energy, environmentally friendly cool chambers made from locally available materials and which utilize the principles of evaporative cooling were therefore developed in response to the problem. Control atmosphere, modified atmosphere storage. Controlled atmosphere or modified atmosphere storage involves adjustment of atmospheric composition surrounding commodities by removal or addition of the gases from the environment surrounding the fruits and vegetables. Containerization. The use of containers for the transportation of goods was recently introduced into India. Relatively, little attention has however been given to the use of containers for the transport of fresh horticultural produce. Containerization provides an excellent system for the shipment of goods from one place to another. Refrigerated containers are used in transportation of fruits, vegetables and flowers in many developing countries. Rapid transport system. Railways and roads are two important transportation systems for the movement of goods in India. The use of railways for transportation of fruits and vegetables in India could be greatly enhanced by making provisions for cooling and ventilation, providing improved handling facilities at platforms, and providing storage space to accommodate the goods upon arrival at their destination. Similarly, road services could be considerably improved by widening roads, by upgrading surfaces, and through the introduction of one-way traffic. Issues and constraints faced by processing operations include technical issues, institutional issues, raw materials and infrastructure, access to external inputs, marketing infrastructure and marketing systems, and why we require a certification. Certification provides a bridge of confidence between consumers and producers, demonstrates commitment to quality, enhances credibility, and adds value to the product. Benchmarked standards. As a result of the work of Task Force, the Global Food Safety Initiative has benchmarked 4 standards in compliance with the 4th edition of the guidance document containing requirements for the food safety schemes for the food industry. One is the BRC standard, the Dutch HACCP code, the SQF 2000 code, the International Standard for Auditing Food Suppliers. Now coming to the levels of certification, there are 3 SQF 1000 certification levels are. The level 1 includes the food safety fundamentals. Level 2 is accredited HACCP based food safety. Level 3 comprehensive quality management systems and development. So this is all about the post-harvest handling, marketing and distribution of foods. So hope you have enjoyed this session. We will see you in the next session.